It's good to be amongst you and share our view and vision and strategy that we are following in 5G Innovation Center and recently launched 6G Innovation Center at the University of Surrey. I hope there is enough material there for the researchers, whether they're from academia or from industry, to could get engaged with at this early stage. So what I would like to just remind ourselves with the 5G and the roadmap of the 5G standards. As you know, enhanced mobile broadband aspect of 5G is finalized together with ultra reliable, low latency. And as far as ITU requirement is concerned, the full 5G is done. But there are important aspects of the 5G, which is makes 5G different from previous generation system, and that is more on the guaranteed reliability and low latency, as well as the use cases, which could be the subject of release 17, release 18, and we could have release 19 and 20. So 5G is evolving for many years. As you can see, the horizon, it could go all the way to 2030, evolution of 5G itself. But nevertheless, in ITU, there's a discussion about 6G, and some academia in the world, as well as industry, they started the research on 6G. There will be, in a couple of years' time, there will be study items on 6G in ITU and the working items, and we'll see 6G will be in full pace going forward. So be having that in mind. What is remained from 5G, together with the use cases, is mainly the automation side. It is the communication or connectivity for the devices. And devices is not necessarily small sensors. It could be as big as a car or a drone or UAV or even trains or whatever. So it is these two aspects, which is mass connectivity of devices, reliability and low latency is yet to come. And together with the high speed enhanced mobile broadband, it will complete the whole picture of the 5G. And in terms of researches that needs to be done in 5G plus or 5.5G, some of them I've listed here. Flexible spectrum access up to 100 gigahertz in a licensed band. High resolution massive MIMO for high precision channel state information and pre-coding, and high capacity uplink, because so far most of the activity on the 5G has been on the downlink for high capacity. Now the attention for some use cases has been put on the enhancing the capacity of the uplink. And new application like XR Pro with higher network capacity and quality, in order to bring into life virtual reality and augmented reality type of applications. Positioning and low power, high precision positioning will be introduced in release 18 of the 5G. High capacity URLC, because of the high reliability, URLC is so far is a low capacity and low data rate, and that is sacrificing high reliability for a spectral efficiency or the throughput. We we all know that we have narrowband IoT for massive machine type communication, but it is extremely narrowband for some of the applications. So reduced capability of the eMBB is now going to be subject of the release 18 to see what is the medium, rather than narrowband, medium band type of access technology for IoT. So with this, we'll have broadband, which is eMBB, we have medium band, and we have narrowband IoT for different applications. Fixed wireless access, there's more work needs to be done, and as well as bringing into 5G broadcasting and multicasting aspects. And gradually we'll see 5G is going from terrestrial into the space, the satellite communication. And the standards in release 17 and 18 is focusing on satellite 5G. Synchronization, time synchronization, again, is part of the 5G evolution. And I will talk about all of this with respect to our vision on 6G later on. And edge computing. Most of the functionality, especially for mission critical applications or time critical applications, more effort is need to be done on the edge computing from the computing point of view, processing point of view, and scalability point of view, and network management and automation. So full 5G will be so complex that it will be impossible to be managed and operate with human operators. So we need to bring AI and machine learning into fully virtualized 5G and flexible with the network slicing. So the network orchestrator, it can make and manage the resources and make the right decision at the right time, and much faster and much more reliable than human operators can do. So this is another area of the hot research area, how AI and ML, it can help us to automate the 5G itself, in addition to what they can do for the automation of the vertical industry. In last November, when we launched 6G Innovation Center, we had 2 days of two-day event. The first day we had what is 5G and 5G evolution. And the second day was more specifically about the vision, worldwide vision from different parts of the world, representative of different companies. They came, as well as European Commission. They came and to present their vision about 2030 plus would look like. So this statistic I'm sharing with you, it is mainly from the second day. We had 8 speakers, which included myself. So the statistics here is about other 7 speakers. And what they mentioned, and the speakers were from Nokia, from InterDigital, from British Telecom, from Vodafone, Samsung, and many other from different parts of the world. So 6 people out of the 7 said 6G is more about fusion of virtual and physical world. I will explain that one later on in the talk. Nearly six people as well, they said coverage is important goal in 6G. Spectral efficiency, again, it was raised by everybody, and use of AI and machine learning. And also there was more emphasis on the greater societal and industrial challenge that 6G needs to address. as well as the sustainability of the environment, energy efficiency. Only two people or two organizations, they set some key performance indicators in terms of the speed they require, like people talking about terabits per second, without any real justification behind it. And in terms of the latency, call it extreme latency, without saying why we need extreme latency. And anyway, only two people had KPIs. And holography, which is the same as virtual and physical world interactions. Anyway, intelligent surfaces was identified as important technology for 6G. I will mention about our work in intelligent surfaces later on. I have a video to share with you. And security and trust. Everybody is realize the importance of the security, trust, resilience of the network itself. So on the right-hand side, I can summarize that people talk about not only communication only, but communication and sensing and actuation, to bring sensing and actuation into the communication. But terahertz communication and huge amount of computing and processing, that people will generate a lot of contents. And the typical more than 50-year-old receiver and transceiver architectures, or the computing architecture, people say with this huge amount of computing and processing and probably speed and etc., the Van Neumann architecture may not be really suitable for future transmitter and receiver architectures. And the signal processing and computing needs to move from more linear processing to nonlinear algorithms. And obviously collaborative machine learning and AI in different aspects of the network. Satellite was raised, and especially mega constellation of the satellite. Trust and multilateral trust, especially for devices that are engaged in a subnet of Internet of Things, and more aggressively than what 5G and evolution of 5G is going to provide in terms of geolocation and positioning, sub-centimeter geolocation, a different environment, indoor as well as outdoor. And high quality time and synchronization was identified. So one lesson that we learned is from this summit that 5G is very capable technology and is evolving over the time. It could be for the next 8-9 years evolves. And another important lesson that we learned, that 5G plus AI is not necessarily equal to 6G. We need to come up with a 6G with a capability that it is beyond 5G capability and requires new standardization or new technologies. So in 5G Innovation Center, or now 6G Innovation Center, we discussed with our industrial partners about more than a year ago. We said, okay, we are getting to sort of midpoint, or probably 3/4 of point into the 5G, and what should 6G be? And we debated and discussed for more than 9 months. And this is advisory board on the 5G, which is the senior people from industry, from operators, from the manufacturers, etc. They were involved in this discussion, and broadcasters like BBC as well. We we thought that the way that 1G to 2G to 3G to 4G evolved, and the same manner, it is unsustainable. And we need to come up with a different way of approaching 6G. So we said, let's start with a very clear use case that has a very clear business case for the stakeholders that can make money out of it. So that was one of the main criteria that we identified. And the second one was, let's not to set any KPIs. Let's not set, we need 1 terabits per second or 100 gigabits per second or latency or whatever it is. So let's do the research and find out what is the art of possibility. What can we do? And for this use case or this business case, we need to do research. And then as the result of that, to see what sort of KPI is required after we do the research, rather than setting the KPIs first. It's a system KPIs, of course, that's what I'm referring to. And we have to always consider the 5G capability as well as its evolution. And we need to think about capability which is beyond 5G capability. And we need to consider the social as well as industry challenges in terms of productivity, in terms of sustainability of the environment, and overcoming the digital divide. With this COVID-19, we realized how important access to broadband and communication infrastructure is, and coverage and accessibility to broadband communication was very much appreciated, not only by us as the researchers and industry, but also by the governments. So that was our homework to start with. And we said, okay, if you want to look at a clear use case and with a clear business case, we said that video is important as the media. And if you look at the way that media has evolved, say from 2G all the way to 5G, those who are as old as me, they remember texting and ringtones as the applications. And then in 3G, we had images, two-dimensional images. And 4G, we actually started the video side. And 5G, the two-dimensional video become a three-dimensional video in form of virtual reality. And it is more about virtual and physical world, but there's no interactions. You cannot really interact with virtual reality. I will give you more examples later on. So we thought that 6G, in terms of evolution of the media side, it has to have interactivity between virtual world and physical world. And the interactions, we call that one, the information we need to provide for this interactivity, we call it 4D video. Hopefully it becomes more clear as I go through this presentation. Okay. So we said 4D video. The fourth dimension is the ambient information. The information which defines a person's context. The information about the environment, the information about the activity of the person, as well as including human senses. So all the information plus the communication side. And I presented this idea in 2015 in one of my TED Talks, long time ago. And at that time, when I was talking about this, and I talked about teleportation, and my wife said to me that I'm crazy. But now is becoming the not so crazy, turning the scientific fiction into scientific fact. I will explain how it can be done. For example, if you look at this video, sorry about the noise. All right. Okay. If you look at this video, this person was holoported from east of London into our center, and I had conversation with him over the phone. So I was just pretending I can see him without the goggles. But there is lots of problems with this, or is the shortcomings with this, which I will explain in the next slide. So if you go back again from 1G to 4G, we whatever we have done all this time, we just been able to transmit two of the human senses, which is hearing and seeing. And then we worked on improving the hearing in terms of the audio, two-dimensional, three-dimensional, sort of like 3D video, audio. And the same thing we've done with video and image, which is got 3D sort of videos. And what is missing from this holoportation is interactivity. Because me and that person, we could not shake hands. It would be impossible to shake hands. And so what we need to do to transmit three of other, at least as part of the ambient information, three of other human senses, and more importantly, touch, smell, and then taste. What we need to do if we transmit all these human senses as well as the ambient information, we effectively doing a teleportation. So we require high accuracy time synchronization. We need high accuracy movement detection. We need high accuracy and a collection of the ambient information, including touch, smell, and taste, to be transmitted. So why we call it in teleportation? The simplest form is imagine this environment, which is somewhere nice and beautiful, fresh air, and the sound of the water running, and etc. If we capture all the senses and transmit to this user, together with the virtual reality of this environment, this person and his brain will think that it is in that environment. So it is the simplest form of teleportation. And teleportation, we always thought that from point A, we go to point B. We go to the point B. But sometimes is the information from point B needs to be brought to the point A, which is in a reverse direction, like in this case. Or we can have interactions. This person, this robot, could be interacting with this object and provide all the sensual feelings, touch, smell, and etc., temperature, etc., to the person. Or we could have real-time interactions between real physical world and the virtual world. And that would be interactive transmission between the two sides. Or we could have two people, could be physically at different places. For example, one could be, say, in London, Another person could be, because it is about the UK and an Ireland IEEE section, and another one could be in Dublin. And these two people could actually, by transmitting and receiving the human senses and the information about the context of the users, they could actually interact in the virtual world with each other. And they could shake hands with each other as if they are in the same place. And if we extend this idea and we extrapolate this, we could have sort of multi-party physical and virtual worlds. As you can see, you remember seeing the Kingsman film. I said all these characters are the virtual, and the main actor is in the physical world, but they interact with each other, and they could be shaking hands with each other. They could be walking with each other and in synchronization. To do this, we need high accuracy time synchronization, as well as the high accuracy positioning and movement detection. So because we are all communication researchers, we need to know what sort of bit rates we are talking about, what sort of speed are we talking about. So some study was done and say that for high quality holoportation for a person with 6 foot by 4 inch high and 20 inch wide, for complete person 3-dimensional to be transmitted, we expect about something like, with the today's technology, we need about 4.6 terabits per second. But over the time, I'm sure that this will be substantially reduced with the advancement in virtual reality and video coding and etc. If you look at other senses, like touch, I talked to somebody who's been expert and in human senses and touch and etc. And say per square inch transmit the real touch, we need something between 20 to 50 megabits per second. So for one average size hand of a person, we need 1 gigabits per second. With 2 hands, we need 2 gigabits per second. And the latency is not that critical. It's about 100 milliseconds. But if you want to do interactions in real time, then that will be different. There will be a lot less. Taste and smell is more chemical reactions that are interrelated. For example, you cannot smell things, you cannot taste things if you don't smell it, and vice versa. When somebody told me this, I was surprised, and I thought there's some truth in there. And in terms of the bit rates, we are talking about 10 to 20 kilobits per second. There's not a great deal of high data rate is required for that, but it is more difficult than touch. So in 5G, in 6G Innovation Center, we are working on touch to start with, to how to transmit touch as naturally as possible. So some people may make a mistake. They say that, okay, 5G is going to provide low latency and guaranteed low latency, therefore we have time synchronization, which is not true. Synchronization is different from low latency. So 5G is capable of wireless on the radio side to achieve 1 millisecond latency. But it is for point A to point B, is a single flow. Whereas the synchronization is the time difference between 2 different flows, not a single flow. And 5G was not designed for synchronization. It was designed for low latency, which is from point A to point B. And this flows could be from two people or one person and one robot, or could be two robots or more. So what happens to the applications? It is not about teleportation only in form of entertainment. What happens in 5G, because of low latency and reliability, it enables IoT, machine type communication, with supporting transportation, manufacturing, gaming, and health, and so on. But all of this requires low latency. Some of it, most of it. And it cannot provide interactivity. So with 6G, with the low latency as well as time synchronization, it would enable interactivity so that in, say, cooperative driving or driverless cars can move in a high speed without colliding with each other. In manufacturing, a person can work with a robot and vice versa. Or in a telecare, for health, a GP could appear like a virtual reality to touch a patient, the forehead, and hold the hand, and have that sort of interactions as to a patient and a doctor have in their own practice. And it would enable sort of like teleportation interactivity in the virtual world. It doesn't have to be always between physical and virtual world, but it could be everything in the virtual world. So it will take all these applications with 5G to completely a new level. And more important, equally important to time synchronization is the jitter. Synchronization has to be very low. For example, if these two robots want to work with each other cooperatively, if you have a time jitter, they will exert pressure on top of each other, and they could break each other. So low jitter and guaranteed time synchronization is important for this interactivity. On the radio side, on the wireless side, if we have accurate time synchronization as well as frequency synchronization, we can hugely reduce guard time and guard band, not only within a cell or different cell belong to the one operator, and it could be between different operators, because at the moment we have a guard band between different operators in adjacent bands that are working with each other. When we talk about distributed massive MIMO system, the synchronization is very important for all this distributed ultra-massive MIMO system to appear as one co-located massive MIMO system. Other things would be possible, like very fast frequency sharing and dynamic sharing and spectrum sensing aspect. This is some of the examples I've given on the radio side, but there is more advantage when we do the receiver architecture and transmitter architecture with a high accuracy time. To be honest, when we do research, we never consider time or accuracy of time into our research when we work. And for example, on the receiver architecture or transmitter architecture, we always assume is given, and the time is accurate and time is always precise. But we need to consider that one in the future design of whatever we are doing in research we are doing. As part of 5G 6G IC, we said that our mandate is sustainability of the environment and digital divide. For this, we have been researching on reconfigurable reflecting surfaces, and some people refer to it as large intelligent surfaces. And that can provide coverage outdoor to outdoor, outdoor to indoor, or indoor to indoor, very cost effectively and hugely energy efficiency. And I show you a video that we developed, one of these intelligent surfaces that we demonstrated in November summit, as well as yesterday. We had a workshop and we demonstrated that video as well. But before we do that, is how it works. Effectively, it's like a reflector, but it is more intelligent. And we engineer electromagnetic wave to disobey Snell law. Snell law says angle of incident is equal to the angle of reflector. But by engineering electromagnetic waves, we can have a different directions and different angle of reflection using meta surfaces and the way that electromagnetic waves are manipulated. If we do this, for example, this user would be blocked from this base station because of this building. But by doing reflection, we can cover the areas which is difficult without increasing the power, provide the coverage in this area. So we built two intelligent surfaces. One was a static and one was a dynamic. Dynamic in the sense that it could follow the beam reflector. Reflection could follow the user wherever the user is moving. Whereas a static one, you can fix the angle of reflection, and that would be for environment that you want to provide permanent coverage. Can say the thickness of this material that we provide is 3 millimeter. And for the static one, it is 11,000 cells, unit cells. And we designed it to do plus minus 45 degree reflection. The gain we achieved was 20 dB. The bandwidth was 400 megahertz, and we purposely picked up a very difficult band of below 6 gigahertz to see whether we can do this one, and was about 3.5 gigahertz. But interesting thing is it can reflect the beam with no power, zero power input. On the dynamic one, as you can see here, about 3,000 unit cells, and we achieved 17 dB gain, 700 megahertz, again at 3.5 gigahertz. And the power that we require was only for electronic side to track the user. It wasn't because of the radiation of the beam. So I want to share this demo with you. I hope it plays.
Having a good and meaningful coverage is still a big challenge for all network operators, especially in a dense urban environment where the presence of a large number of buildings and infrastructures gives rise to harsh propagation condition for electromagnetic waves, leading to lack of seamless connectivity. The major reason behind this issue is a lack of control over the propagation environments. So in this case, the propagation environment remains unaware of various communication process going through it. The engineered metasurface is a key to make this such passive environment smart. So this engineered metasurface, also known as large intelligent surface or reflecting intelligent surface or even hypersurface, can enhance the meaningful coverage by sensing the environment, recycling the existing electromagnetic wave and redirecting them toward the direction of interest.
By these structures, you can have a control on the reflected rays. And this is the beauty of these meta surfaces. We can control something that we literally cannot see.
You come across certain places which are called as coverage blind spots. You don't have coverage over those places. And to put up a new base station is quite expensive just to cover a small area. But with these kind of intelligent surfaces, you can cover those blind spots, ensuring that the user always has a seamless connectivity, even if it is moving.
As far as I know, this is the first demonstration in the whole UK.
This is our first scenario to find out the performance of the static meta surface. This is our receiver.
So we are streaming a video here over the 3.5 gigahertz band using software-defined radio from the base station to the UV. The base station is kept here and the UV is kept inside in an area where there's a coverage blind spot. But once we place our surface at the right position, the UV will receive a strong enough signal to decode the video stream and the video will play smoothly. So now I will start transmitting the video stream from here towards the meta surface.
And this process is done by this reflecting meta surface. There is no line of sight from the transmitter and this receiver. If we move the surface, we lose the video. And now my colleague is moving the surface. As you can see, the signal is actually lost.
At 6GIC, we have developed a dynamic version of this meta surface. This meta surface is quite different from the one that you just saw. The previous one that you saw was a static version, which doesn't require any power at all, and it works completely on its own. This one requires a controller. This can actually make the beam change its angle so that the coverage always follows the user and the user has a seamless connectivity.
So just let's try. If I press the reconfigurable mode, you can see now we have video there at the user terminal. My colleague is going to move the user toward another point. Again, you see the video stream is not getting decoded successfully. So now let's again use the reconfigurable mode and let's ask the meta surface to reconfigure itself. Now you can see we have received video because the meta surface reconfigure itself toward the new position of the user equipment. In the last scenario, we are going to demonstrate the capability of our dynamic meta surface to change the angle of the reflected beam continuously to follow the user as it moves, ensuring the seamless connectivity to the user. So let's try it with the tracking mode and let's the meta surface to start follow the user.
In reality, this automatically do everything. It means detect the position of the user, change the beam, calculate based on the algorithm, and do everything automatically. This is a very, very big achievement for the University of Surrey. We don't have anything similar in the world in this size, and these solutions is totally together. I think we are the first.
Okay, I hope you enjoyed that video. And I hope one day when this COVID restriction is lifted, you can come and see this one working in the early demonstration, and we are working on improving some aspects of the technology, and it is currently under the patent filing, this technique. So to overcome the digital divide and activity, we are that 6G will have to have a non-terrestrial segment to complement, not compete, but complement the terrestrial system in a way that to a user, the connectivity is everywhere it goes, is available, and it is seamless. And the challenge is, can we do communication through a health terminal? Not a sort of VSAT type or big terminal or big terminal with the big antennas. And we are working on a number of issues on the power efficiency, on the solar cell. We are working on the space mine technique as well. So coming to summarize, 6G is an integration between communication and sensing, and it will be a network of networks. But this network of networks in one infrastructure, they all cooperate with each other. The smallest network is a wearable and personal area network for the sensing. And then we have wide area cellular networks. And for open areas and bigger areas, we have the satellite networks or the space and non-terrestrial networks. But they all need to be part of the same type of networking and under the same networking management. There is a number of research areas that we are engaged with, and that is, we are working on the 4D video, and I said we are working on the touch to start with, edge computing, large intelligent surfaces, space MIMO system, using AI as much as possible. For terahertz, we're using sensing for the terahertz, and also we are looking to work with people who work on the new materials and synthetic biology, and the triangle, because the famous triangle that we identify 5G capability, is becoming with a similar triangle for 2030 plus. We put coverage, synchronization, and geolocation accuracy of sub-centimeter is the requirements for 6G capability. Obviously, underneath all this is huge energy efficiency, as well as the advanced application area like teleportation will be underneath all of this, and using AI as much as possible. Thank you very much.